Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 1022. Sum of root to leaf binary numbers. Okay, you are given a root of a binary tree where each node has only two values, either 0 or 1. Okay, and each root to leaf path represents a binary number starting with the most significant bit. So the first root node is a MSB. Okay, now for example, the path is 0, 1, 1, 0, 1. Then its binary representation is also 0, 1, 1, 0, 1. So here, this 0 is a root, right? This should be my MSB. Okay, now for all leaf in the tree, consider the number represented by the path from root to leaf and return the sum of these numbers. Okay, they are asking us to find the path to root to leaf and take each and every root to leaf path and add them and give the sum of that path. Okay, now let us see this example. See here, this is my first example. In this, what is root? I can say this is root, right? And what are the leaf? I can say this 0 is a leaf, this 1 is a leaf, then this 0 is a leaf again, and this 0, this 1 is a leaf. So this last level is all a leaf. But how we can say it is a leaf or not? So leaf doesn't have any children. Namely, the left and right will not exist. Which means what? This left and right will be what? Null. So whichever the root has these property, I can say that are leaf. Okay. So what are the path of root to leaf in this example? In this example, I can say this is one of my path. Yes. Then I can say going here and this is one of my path. Yes. And then I can say this is one of my path. Yes. At last, I can say this one of my path, right? So I can say it, I have a 4 root to leaf path, right? Okay. Now, what is the binary representation for the red color path? I can say my binary representation will be, here, I wrongly written the value. This is what? This is 1. This is 1, okay? In question, it is 1, okay? Now, first, the red color path will be 1, 0, 0, which is equal to what? 4, okay? Now, yellow color path is 1, 0, 1, which is equal to 5. Now, what is the next path? It is orange color path, right? Now, orange is what? 1, 1, 0, which is equal to 6. And my purple is what? 1, 1, 1, which is equal to what? 7. So, by adding this, I can get the answer as 22. So, this is my result. Can I understand this? Okay. Now, how can we attain this result? That's my next question, right? How can we attain this result? Okay. If I tell you that we have a root and we can traverse up to the leaf and take that result and return it. Like that, we want to take each and every node's result and the root should return what? The addition of the right subtree and also left subtree. Can you understand this? Okay. Let me visualize it. So just see this example. Here, the first root is this one, right? Okay. Here, whether I want to do a Lavanara traversal or a DFS traversal. I want to do a DFS traversal. It is quite easier, right? Because in DFS traversal, we can go up to the depth. Here also we want up to the path to the leaf node, root to leaf node. It is not by level. Okay. So I will do any one of the DFS traversal. If you can do any one of them, we will get the same answer. I will pick the pre-order. Okay. Now see here, it is 1 initially, right? Okay. I will create an empty list initially. Initially, I will create an empty list. Inside this, I want to put each and every root value instantaneously. Okay. First, it is what? 1. Just put 1. Okay. Next, it goes to what? This 0. Now put a 0. Okay. Now it goes to what? This 0. Okay. Put a 0. Now, it is what? It is a leaf node. It is what? A leaf node. So I can say at my leaf node, I want to return the answer. Because apart from this leaf node, we cannot still go to the path, right? We want the root to leaf node. So this is the root to leaf path, right? So while converting this, how can we convert this? It's simple, right? Just take for example, it is 1, 0, 0. So it is what? By MSP. And this is what? LSP. So LSP should be started with what? 2 power 0, then 2 power 1, then 2 power 2. So I can say 1 into 2 power 2 is equal to what? 4. Then here comes 0, here comes 0. So 4 plus 0 is equal to what? 4 inside. Okay. Now it returns what? It returns 4. It returns what? It returns 4 to it. Okay, because the answer is 4, right? So you want to return what? 4. Okay. Now, what is my next step? While going to backtrack, while I'm backtracking, I should remove this 0. Remove this 0, okay? Now, again, I will go here. I'll go here. Now, this 1 is included. Okay, 1 is included. Now, what is the binary representation? It is 5, right? Okay. Now, while backtracking, I will return this 5. I will return this 5. While backtracking, I should remove this 1 also. Can you understand this? Okay. For this node, 0, I finish left subtree and also the right subtree, right? So, what is the sum I got? I got the sum as what? 4 plus 5 which is equal to what? 9. I will return what? 9 now. Okay. Now, while backtracking, what should I do? I should remove this, right? So, I will remove this from the list. Okay. Now, I'm going to what? I'm going towards the right subtree. Okay. I'm going here. It is what? 1. So, I'll include 1 here. Okay. I'm going to what? Now, left subtree. Yes, this is pre-order traversal. Again, if you don't know about the pre-order traversal, just go back to my video and watch it. I will give the link in the description, okay? Now, the 0 will be included here, okay? Now, what is the decimal equivalent? It is 6, right? And also, it is a leaf node. That's why we are returning, right? Whenever there's a leaf node, we want to return what? The answer we got, okay? Now, I will return what? I will return 6, right? 6 is the answer we got. Now, I should remove this 0 hertz. So, yes, then it goes to here. Now, 1 is added. Instead of 0, 1 is added, right? Now, it is what? 7. It is what? 7. So, it also returns what? 7. Okay. Now, for this node, I finished the left subtree and also right subtree. So, it returns what? It returns the sum of them both. So, what is the sum of them both? It is 13. Now, for this one, I finished the left and right subtree, right? So, it will return what? Sum. So, 13 plus 9 is equal to 22. So, it returns what? 22. We got the answer. We got the answer, right? Yes. So, this is our first approach. Okay, this is our first approach. Now, just tell me whether this list is necessary. Because it also takes some space, right? It also takes some space. Whether this list is necessary. No. Because we can compute this without this list also. Yes. Take for example, if I have a path like 100. Take for example, I have a path like 100. Okay. Then how can I compute it? First, I will get this one, right? First, I will get this one. Okay, let me put a pointer here. Then I go to this 0. While taking this 0, I should place where? I should place 10 like this only, right? So I should shift to what? This one time, and I will add what? The 0. Such that the answer will be what? 10. Can you understand this? Okay. When I'm going to this another 0, my results will be what? 100. So I will another time left shift 1 time and add a 0. Such that it will be what? 100. Can you understand this? Okay, let me try with another example. 110. Let me take this value. Okay. Now, first of all, my pointer is where? At this one. Like I'm telling you, like traversing the tree. I already taught you how to traverse the tree and take that into a result. Now it's what? It's bit optimization. Okay. Now, this one will be taken. Okay. Now, again, this one. So, I will right shift 1 time with plus 1. Plus 1 is equal to what? 1. So, what is the decimal equivalent for this 1? It is 3. It is 3. Okay. Now, wait, I am going to the next point. It is what? 0. So, I should left shift 1 plus 0. So, it's equal to 6. So, I got the answer, right? Can you understand this? So, what we are doing here? Whenever we are taking the current sum, just do a current sum into 2 plus that root's value. That's it. It is simple. Why you want to go and put in a list, then pop out by backtracking? It's unnecessary, right? Okay, what is the time and space constraint for this solution? I can say my time and space constraint will be O of n for time, because my time will be decided by what? By deciding we are visiting each and every node, so that my time will be O of n and space will be what? O of h. You may ask, what is h? So h is what? Height of the tree. Because while backtracking, we will delete this stack, right? We will include. While backtracking, I will delete, so that it will be what? This height only. The internal stack will be what? Size of height only. Okay. So this is my time and space constraint analysis. Now it's time to see the code. While seeing the code, it will be more clear. See here, this is the code. First of all, I am just using a code to convert this binary to a decimal. Okay. In this, what should I take? A result. Then I'm taking a multiplication. Like it is initially 1, then 2, then 4, then 8. That's what the representation, right? Now, for I am using the for loop to iterate to that list in a reverse order from the right to left. Now, result is equal to num of I into multiplication. So if it is 1, if the current bit is 1, then only it will take that multiplication, right? Okay, now multiplication into is equal to 2. First it will be 1, then 2, then 4, then 8, then 16 like that. Okay, now at last I will return the result. So this is the code for converting the binary to the decimal, right? Okay, now come to the next here. So DFS of root comma val. Okay, now if not root, then what should I do? I should just return 0. That's it. If it is leaf, then I should append my val as what? The root dot value. I should take the root dot value in my list. Again, see here, this is what? Val. This is what? Root dot val. Root dot val is the attribute of the tree node. This val is what? This val is my list. Like the list I have created now. Okay. Now, if not root dot left and root dot right, it means what? If it is a leaf node, then what should I do? I should take the binary representation for that value, for that current value. Then I should pop that list last value. Yes. Then I will return the B. Can you understand this? Just observe this. 1, 0, 0. Yes, this 0 is a leaf node. Then while backtracking, what should we do? We should pop this 0 out and also take that 1, 0, 0 value, right? And return it. That's what I've done here. Okay. Then I will do DFS traversal for a left node and also for a right node. Then I will pop the value. After, while I'm backtracking. While backtracking, what should I do? I should pop the list node, right? So I'm doing that. Okay. And I'm taking the sum and returning it. L plus R is a sum. If the node is not a root, then what should I do? I should return the sum, right? I should return the sum. That's what I've done here. Okay, then I'm calling this function. That's it. Let me submit it. Yes, it is submitted successfully. Now it's time to see the second approach. Like we don't want to compute in a list. We just compute by using what? Bit manipulation itself. Okay, see here it is quite smaller. See here, DFS of root comma val. Now, if not root, what should I do? I just return 0. If it is a leaf node, what should I do? I just return value into 2 plus root dot val, which means what? I want to take the current sum into 2 plus the root dot val. That's what I've done in the drawing explanation also, right? Now, value is equal to value into 2 plus root dot value. I'm doing this, and then I just go on and traverse to a left subtree and also the right subtree and take their both sum. Okay, take their both sum and I will return it. Simple, right? Simple. Okay. You may ask why I am using this not root. Okay. So let us do an example. Like I having 0 here 1. So this is my tree. Let's consider this is my tree. Okay. At first I will traverse this 0. So 0 will be in my current sum. And when I am coming to this 1, this will be what? 0 left shift 1 plus 1 is equal to what? 1 only. Is equal to what? 1 only. Now I will backtrack. Then it goes here also, right? What is here? It is null. So we should return what? 0. Such that it returns what? 1. It returns what? 0. So 1 plus 0 is equal to 1 only. Can you understand this? If any node has only one child, then this null value will be returned, right? That's why we are returning a 0 in a null value. Okay, I forgot to tell you in a previous approach code itself. Okay. Now, that's all about this code. Let me submit it. Now, I didn't call this function return a DFS of what is the root? It is root only, 0. That's it. Let me submit it. Yes, it is submitted fully. Thank you.
The other dot. And then it's to be